illumination, the surprising frequency of multiple, independent, simultaneous discovery. Elisha Gray was an inventor, and a good one. He'd studied the emerging science of electricity at Oberlin College and worked there as a teacher and demonstrator. And in his spare time, he worked hard, applying the ideas he was exploring to the world of practice. By 1867, he'd invented a number of useful devices and filed his first patent, one of over 70 which he'd file in his lifetime, which concerned an improved telegraph relay. He was also a pretty smart businessman. In 1869, he set up Gray & Barton as a company with his partner Enos Barton, supplying equipment to the giant Western Union Telegraph Company, which dominated the emerging field of telecommunications in the United States. It all went very well. External financing helped them move to a new facility in Highland Park, Chicago, where Gray changed position to chief engineer, concentrating on product development. A good move. By 1870, he developed and patented commercially successful devices, including an early voice annunciator for hotels and elevators and a microphone-operated printer. In 1872, Western Union had become a major shareholder and changed the name to the Western Electric Manufacturing Company. It's still there today, though the name and makeup has changed many times. The current legatee is Nokia Networks. Gray was able to step back from running the business and concentrate full-time on inventing. And on December 29, 1874, he gave the first public demonstration of his invention for transmitting musical tones, transmitting familiar melodies through telegraph wire. This work culminated in his being awarded a patent, number 166095, in 1875, for the electric telegraph for transmitting musical tones, essentially the foundation for acoustic telegraphy, which also makes him a sort of great-grandfather of today's streaming industry. He'd certainly qualify as one of Spotify's godparents. So it wasn't a surprise to see his attorney filing a patent application for another device to enable transmitting vocal sounds telegraphically a year later, on February 14, 1876. The accompanying information described it as something which would transmit the tones of the human voice through a telegraphic circuit and reproduce them at the receiving end of the line so that actual conversations can be carried on by persons at long distances apart. Unfortunately, another inventor had also submitted an application on the same day and 5 hours earlier. One Alexander Graham Bell. Bell's was the earlier, and so his patent, number 174465, was granted for the device offering an improvement in telegraphy, pipping Gray's at the post. 2 years later, the gloves came off, and on September 12, 1878, lengthy patent litigation began between the Bell Telephone Company and the Western Union Telegraph Company. It's a fascinating story. Both men could lay claim to working on the ideas which led up to the telephone, and both could demonstrate different evidence to support this in the form of lab notebooks and so on. In the end, after extensive wrangling about who filed what and when, and allowing for formal challenges and counter-challenges, the US Patent Office finally ruled in Bell's favor. Now, we'll never know for certain who was the real father of the telephone, but it does give us some insight into how simultaneous innovation can come about. It's certainly not the random visit by the same muse to two different people. It's got much more to do with progress along trajectories, which begin life as dusty, half-formed tracks, but end up as major highways carrying innovation forward. We can see the same pattern with the electric light bulb, once again an innovation of unclear parentage. Scientists were working on the concept around the world, and there's still argument as to whether Joseph Swan, Thomas Edison, William Sawyer, or Alban Mann was the father. Mann received a US patent for the incandescent lamp at around the same time as Swan patented his light bulb in England. And like Gray and Bell, there were plenty of arguments around whether Edison infringed both of these. It didn't really matter. Inventions of themselves don't create value. They need to be developed into working solutions and then adopted at scale, which means putting together a much wider system of complementary assets. The inventorship issue became resolved through intermarriage to help bring the idea of the light bulb to scale. Edison's lighting company merged with the Thomson-Houston Electric Company, which had the Sawyer-Mann patent, to form General Electric. And his English lighting company merged with Joseph Swan's to form Ediswan in England. Both of these cases reflect the progress of science and the presence of communities who communicate ideas and experiments. There's a buzz across the networks which alerts people to the same interesting problems. But sometimes it's just plain old frustration which is the driver, rather than the quest for scientific prestige, and it leads to different people working on the same problem in different, unconnected locations. For British housewife Valerie Gordon Hunter back in 1947, the annoyance at the endless process of washing nappies for her 3 children made her dream about some kind of disposable version. She looked around, couldn't find one anywhere, and so invented her own, the paddy. It was a 2-part garment made of old nylon parachutes, tissue wadding, and cotton wool. She made hundreds of the nappies using a sewing machine at her kitchen table, supplying friends with the product and constantly modifying the design. But she wasn't the only mother with this sense of frustration. At the same time, and across the Atlantic, Marion Donovan came up with the idea of a cover which would stop the contents of a dirty nappy from soiling surrounding clothes or bed linen. Once again, the target was reducing the superhuman effort involved in constantly washing clothing. Her invention was called the boater because of its resemblance to a boat. It involved a shower curtain as raw material sewn into a pair of pants, which, with the addition of snap fasteners to replace safety pins, kept the nappy in place without soiling the surrounding clothes or bed sheets. And she hit upon the idea of some kind of absorbent insert which could be disposable, experimenting with various mixes of cotton wool and, once again, nylon parachute material. Whilst rubber pants were already available to cover traditional nappies, their effectiveness at keeping the contents in had the downside of being uncomfortable to wear and giving babies nappy rash. Despite plenty of interest among local mothers, she couldn't persuade anyone to manufacture the boater, so developed and patented it herself. On its launch in 1949, it was a runaway success. As the president of Saks Fifth Avenue store wrote to her, "It's not often that a new innovation in the infants' wear field goes over with the immediate success of your boaters." She didn't stop there. She began looking for a way of replacing the insert with a fully disposable version, and after experimenting with different kinds of paper, and once again finding no manufacturer prepared to take her idea seriously, developed her own. Meanwhile, in another part of the country, Victor Mills, a researcher with Procter & Gamble, also had the frustrations of nappy changing for his grandchildren as a source of unlikely inspiration. Equally fed up with the difficulty and accompanying mess of changing, he set up a research project to improve the experience by making a disposable nappy. After experimenting with various materials, they came up with a garment based on polyethylene wrapper around an absorbent paper pulp filler. And in 1961, Pampers were born. 50 years later, they sold around $10 billion worth around the world. Now, multiple independent invention is surprisingly common. There have been many research studies highlighting the pattern. Examples include the blast furnace, which was invented independently in China, Europe, and Africa, and the crossbow, again invented independently in China, Greece, Africa, northern Canada, and the Baltic countries. And those studies reveal an important home truth about how innovation actually happens. It's not the Archimedes moment, a flash of inspiration given by the gods at bath time. Instead, it's a process of hunting, of being open and aware of opportunities as needs and means converge. The idea of closeness is key here. As things mature, knowledge accumulates, so we get to a tipping point where something is bound to happen somewhere. Like crystallization, the supersaturated liquid is ready, it just needs the seed, a speck of dust or some other impurity, and the crystal starts to form. It's what Stephen Johnson calls the adjacent possible. Innovation arising out of a soup of possibilities which has come to the boil. It wouldn't have been possible earlier because the right conditions weren't present. Take the emergence of the bicycle, which began with experiments in personal transportation back in 1817, with Baron von Dreis's attempt at horseless personal transportation, the Dreisien. The need was there, exaggerated by the shortage of horses brought about by European crop failure and the ravages of the Napoleonic Wars. But it took another 70 years before the necessary technological means, around precision machining and improved metal alloys, emerged to enable William Starley to launch the Rover bicycle and capture the mass market. This also explains why many apparently great ideas don't succeed. Their failure isn't down to bad ideas, but rather to bad timing. Entrepreneurs innovate by bringing needs and means together, but often their knowledge of the need side far outstrips their ability to find suitable means to solve the problem. It's all about experimentation, and many experiments fail because they aren't mature in terms of the solution they offer. Think about vacuum cleaners. The problem of sweeping the floor has been around since the Stone Age, and various solutions emerged over time. But the idea of using mechanical power to handle the problem came to many people in the late 19th century, and they experimented with different ways of realizing it. Some were more cumbersome than others. One example was John Thurman's pneumatic carpet renovator, which he developed in St. Louis in 1898. This used a gasoline engine which produced a powerful blast of air, not so much sucking as blowing the dirt into a bag. The idea was interesting, and the results reasonably effective, but it was something less than a portable device, coming in the form of a big machine towed around on a horse-drawn carriage. He charged $4 a visit for the service. Its limitations included being very loud and also having the side effect of scaring the horses. It was a one-time inventor, down on his luck and working as a janitor in an Ohio department store, who solved the problem in a way which was scalable. In 1907, the 60-year-old J. Murray Spangler was not enjoying work. His chest had never been good, he was asthmatic, and the last thing he needed was a job which involved swirling up lots of dust as he pushed the company's old floor-sweeping machine around. So he set about trying to improvise something better, using a wonderful mixture of whatever came to hand. A broom, a leather belt, a pillowcase, an electric motor culled from an old ceiling fan, a rotating brush cannibalized from a broken carpet sweeper, and an old soap box. He played around with a contraption which had the distinct advantage of being portable and upright, and in 1908 was awarded US patent number 1073301 for his electric suction carpet sweeper. He borrowed money, persuaded friends to invest, and began trying to make the machines, but to no avail. He couldn't raise enough to set up manufacturing and was only able to make 3 machines a week, even with the help of his son and wife. It looked like he was about to fail again, but fortunately he'd given a test version of his machine to his cousin Susan. She was delighted with his performance, enthusiastically telling her husband about this great new machine. Which is how it came about that William Hoover branched out from the leather goods business and into the world of vacuum cleaners. buying Spangler's patent in 1908 and beginning to build the business which was to make his name and fortune. Hoover knew about the potential market, and Spangler's patent gave him the key to unlock it. This right place, right time theory helps us understand how simultaneous, independent innovation emerges. Adjacent possibilities create the conditions for convergence, ideas whose time has come. Needs which might have been around for a long time can be met through novel configurations of means, new technologies, new social structures, new regulation, and so on. For the first mover, this is a crystal moment when the possibility becomes reality. What follows is an inevitable swarm of imitators trying to exploit their version of the core idea. Which makes it important to be actively connected, aware of developments outside, and the experimental successes and failures of others in your field of interest. A great deal of R&D effort is spent keeping up with the field and tracking what competitors and others are playing around with. And one of the weaknesses of our patent systems is that they involve disclosure. And when someone discloses, you can get an insight into what they're doing, and then try and find a way around their idea. Now, this kind of communication-led innovation preparation dates right back to Gutenberg and the arrival of printing as a way of sharing ideas. But in an era of open innovation, where communication is more extensive than ever and runs across so many parallel tracks in the metaverse, we should expect to see more hints and nudges about promising new ideas in the wind. All of which suggests two important lessons for managing innovation. First, keep your ear to the ground to pick up early warning signals of convergence. And if you're the one doing the converging, then make sure you're going to be able to defend your position.